This is training session for partners who sell the shared services offering, or in other words, control room as a service based on the central event management offering of Takadu. Through this training, partners will learn how to deliver a value proposition presentation to potential end client utilities. The central event management solution is a 24/7 water network monitoring solution oriented for distribution water utilities. The solution uses the data from the network meters such as flow, pressure, level, and so on. It processes the data by employing machine learning techniques for detection of diverse asset failures types such as leaks, oftentimes much earlier than other indications or public reports. In addition, the solution is a platform for managing the remedial activities along the incident's lifecycle. The solution is cloud-based with fast onboarding and easy integration. Utilities that adopt SAM experience the following benefits: visibility of the network operation. Early detection of leaks leads to water loss reduction over a long period of time, sometimes even 12 to 18 months, till those leaks burst on the surface and become visible in other ways. Higher operational efficiency, as fixing network incidents shortly after they start is simpler and faster, cheaper, and enables do more with less. Better customer service, as early detection reduces the number of customers' complaints. Retaining organizational knowledge by replacing the hard work of veteran employees who gradually leave or retire with automatic detection solution with embedded best practices. Let's look behind the scenes how the system detects typical leaks. In step 1, the network meters record flow data and broadcast it to a central data repository. The utility extracts this data and sends it through integration to the same cloud for processing. In step 2, the system uses that data alongside the historic data it already has, plus the data from other zones, for learning the expected flow behavior in each zone. We call this predictions. When needed, the system cleans data outliers and complements short data gaps automatically. In the graphs we see on the slide, the green line represents the prediction and the blue line represents the actual data. In stage 3, the system compares between the actual data and the prediction. During normal behavior, which is most of the time, there are no gaps between the actual data and the prediction. A gap between the prediction and the actual data is an anomaly. Based on the auto-learning of the behavior in each zone, when the anomaly is significant in duration and magnitude, the system raises a leak event. We notice on the same graph normal behavior when the graphs overlap, as opposed to the time of the leak when the gap between the graphs is significant. The cycle between stages 1 and 3 occurs automatically every hour 24/7. Stage 4 is optional and operates in parallel to stages 1 to 3. The system receives, through integration, information from other systems, such as work orders, and presents them in conjunction with the events the SAM detects. The external information provides additional perspectives about the same problem and helps operators with their decision-making. In addition to leaks, the system detects additional asset failures types such as faulty meters and telemetry problems, high and low pressure and pressure-reduced valve degraded performance, water breach between adjacent DMAs, degraded water quality, and sewage blockages. Besides detection of events, the system is a platform for managing the events, and as such, it calculates and presents certain decision-supportive data about each event, enables modifying certain attributes, attaching files, and writing comments. Starting with these slides and continues with a couple of more, we'll describe a selection of examples. Event type and magnitude, enabling to write and view comments, a map of the DMA with assisting information, calculating the start and finish time of the event. Recording all changes events are going through and presenting them as a log. Calculating the event's duration, calculating the estimated water loss in volume and dollar value. A special indication when the anomaly ends and users can safely close the events, file attachment, tagging events for future analysis, and updating the event's status. By now we described what the SAM is, how it works, and what the benefits and values from using it are. In the next section of the presentation, we'll describe the next building block of our offering, control room service based on the SAM. Our professionals operate from a centralized control room we established. They monitor the events the system detects, analyze them, and contact the end client utility daily with a prioritized list of events to handle. Later in the same daily interaction, our professionals collect information about the utility's progress with events they shared in the previous days. Based on the utility's feedback, our professionals update the events and close them after fixing the problem. Utilities may opt to assign users for viewing and updating the events together with our control room. Let's review the roles and responsibilities of the utility, the control room, and the SAM along the service lifecycle. The utility is responsible for developing automatic scripts that collect the data from the network sensors and upload it to the cloud in predefined schedules. The SAM works constantly in the background and processes fresh data automatically, detects new events, and updates existing events. Professionals in the control room analyze new events, notify daily the utility about a prioritized list of events to handle, and collect feedback about events in progress. Dedicated personnel of the utility continue with analyzing new events and deploy field teams to fix faulty assets. The SAM continues working in the background, processes new data that arrives frequently, and employs the automatic repair verification process for validating the problem was solved prior to closing the events. In due time, professionals in the control room close every event. The next two slides demonstrates testimonials and the value utilities experience. We see points like water loss reduction, strong return on investment (ROI), improved customer service, and better visibility of the water network. We offer our 2-month onboarding plan. We exercise this process many years globally. It includes guidance and help about how to collect and share with us the essential network data, developing a non-invasive integration for collecting and sharing the ongoing data the network sensors record, testing the solution before going live, and user training. In the following slides, we'll view few of the models and how typical events look like. First example of a typical leak event. Second example of a leak event. Reports and dashboards. Geolocation, an advanced module for helping utilities narrowing the location of leaks within the DMA. This module can only be set to operate after using the solution for a while, provided the GIS data is accurate and each DMA includes 3 to 5 pressure sensors. Works by performing what-if analysis about optional leak locations and evaluating each location through a comparison between certain KPIs the system calculates and the actual data measured by the network meters. Detection of apparent losses through an unauthorized water consumption report. Functional degradation of PRV pressure reduced valve. Water breach between adjacent DMAs. Low pressure events. Negative events imply on DMAs that are not closed supply zones. Faulty meter and telemetry events. The essence of our offer is based on the following: 12 months pilot, including the onboarding phase, network coverage to be defined, 2 months onboarding, control room as a service, and support services. Experiencing value is a gradual process. We advise everyone that the adoption leads to transformation. We advise to take the time and adopt the solution gradually and walk before you run. Few notes about the company Takadu and the SAM solution. We're talking about a global use since 2011. Takadu invented the concept of data analytics for water networks. The technology is protected with patents. We're talking about a matured offering with quick deployment, easy to use with built-in best practices, and the company continues developing new offerings. Are there any questions? If not, thank you very much.